In this video, we'll see what are trigonometric identities. Before understanding trigonometric identities, we have to understand what is an identity. You must have seen a particular algebraic equation in math. A plus b whole square is equal to a squared plus b squared plus 2ab. Have you ever wondered why is this called as an identity? That is because it holds for all values of a and b. No matter what value you take for a and b, it will always be true that a squared plus a plus b whole squared will be a squared plus b squared plus 2ab. Similarly, there are many other algebraic identities also, and you must have come across them, which are like a minus b whole squared, a cube plus b cube, a minus b whole cube, and so on. So then what do we infer when we say that this is an identity? An identity is an equality. That means first of all, it will have an equal to sign that holds true for all the values of the variable. There is no exception to this rule. That means no matter whatever value of the variable you put, the left hand side will always be equal to the right hand side. So that means trigonometric identities are those identities that will hold true irrespective of whatever angle we put. Let's take an example. Tan theta is equal to sine theta over cos theta. First of all, it contains an equal to sign, so this is an equality. Secondly, it is true no matter whatever angle we input into this equality. If it holds false just for one angle also, but it is true for many other angles, but just for one angle also, it does not hold, then it will no longer be an identity. So while studying trigonometry, you will come across three very popular trigonometric identities, which are: the first one is sine square theta plus cos square theta is 1. The next is 1 plus tan square theta is sec square theta. And the third is 1 plus cot square theta is cosec square theta. So let's have a look at the first identity. Sine square theta plus cos square theta is 1. We take the help of a right angle triangle and let angle A be theta. The side in front of the right angle triangle, the side in front of the right angle, that means in front of angle C, that means side AB, is the longest side of the triangle. So that is already the hypotenuse. If we look at angle A, the side which is opposite, that means in front of angle A, that is side BC, will be the height, and the side which is attached, joined to this angle, will be the base. So as we have seen in the previous videos, the definition for sine function is sine theta will be height over hypotenuse and cos theta will be base over hypotenuse. So now, since in the identity we have sine square theta and cos square theta, we square the trigonometric functions. So sine square theta will be height square over hypotenuse square. We just have squared both the sides of this equation. And cos square theta will be base square over hypotenuse square. Now we just substitute the values of sine square theta and cos square theta into this identity. So sine square theta was height square over hypotenuse square. Cos square theta was base square over hypotenuse square, and we add both of them. So we are actually starting with the left hand side of this identity and checking if it actually equals 1. Since the denominator is common, hypotenuse square, we just add the numerators height square plus base square over hypotenuse square. Now we know from Pythagoras theorem that height square plus base square is hypotenuse square. So we had height square plus base square over hypotenuse square right now. And since the numerator is also hypotenuse square, both of them get cancelled and we get 1. Since we started with the left hand side, substituted values of sine square theta, cos square theta, and we got 1. And the right hand side was also 1. So the left hand side is equal to the right hand side. And sine square theta plus cos square theta is equal to 1 is an identity. Now we look at the next trigonometric identity, which is 1 plus tan square theta is sec square theta. To prove this, we can use the triangle method like we did in the previous case by substituting the values of tan and sec. Or what we can do is, we can use it we can prove it using this previous identity, that was sine square theta plus cos square theta is equal to 1. Let's see how. Again, we start with the left hand side first. We know by definition that tan theta is equal to sine theta over cos theta. So squaring both sides, we will get tan square theta is equal to sine square theta over cos square theta. So again, we substitute the value of tan square theta in the left hand side of this identity. So 1 plus sine square theta over cos square theta. We take a common denominator and we get cos square theta plus sine square theta over cos square theta. And as we have seen in the previous case, sine square theta plus cos square theta is 1. So we get 1 over cos square theta. Now we know the relationship that holds between sec theta and cos theta, which is that they are reciprocal of each other. So the last step was 1 over cos square theta. And since the relationship between cos theta and sec theta is reciprocal, so 1 over cos square theta will be sec square theta, which is the same as right hand side. So this is a trigonometric identity. Now we have the third trigonometric identity. 1 plus cot square theta is cosec square theta. Again, we do the same thing. Either we use the triangle method, or we use the definitions of these functions, or we used it using the previous identity. Again, like we did with the previous case, we start with the left hand side. Now cot of theta is cos theta over sin theta. So on squaring, we get cot square theta is cos square theta over sin square theta. Again, we substitute the value of cot square theta in the left hand side of this equation and we get 1 plus cos square theta over sin square theta. We take the common denominator and we get sin square theta plus cos square theta over sin square theta. And the numerator is already shown to be 1, so it becomes 1 over sin square theta. And we know of the relationship that holds between cosec and sine, that they are reciprocal of each other. So the last step that we obtained was 1 over sine square theta. And since sine and cosec are reciprocal of each other, this becomes cosec square theta, which is same as the right hand side of this equation. So this is also a trigonometric identity. This is it for this video. We'll see more of trigonometry in the next videos. Bye bye.